Hello everyone, this is Mahesh and today we are going to solve Leetcode problem number 3, longest substring without repeating characters. So we are given a string and we need to find the longest substring without repeating characters. That's the problem statement, and if you look at the example 1, so the given string is abc, abcbb, and longest substring that we can form out of the string is like abc or bca or cab, and as all of them has same length, we can just return length as 3. We're not asked to find the longest substring, instead we're asked to find the length of the substring. Okay, now let us see how we can solve this problem. Okay, so we can solve this problem in 3 different ways. Number 1 is a brute force approach, which is creating as many substrings as possible. Okay, so we can create substrings out of the original string like this. So the substrings are going to be A and AB and ABC and ABCA and so on. Okay, all the substrings starting with A. Once this is done, we repeat the same process for B, C, and all of them. So for B, it's going to be B, BC, BCA, and so on. After that, we repeat the same process for C and all the other characters. So after creating these substrings, we need to write a function which will look at all these substrings and eliminate any string which has duplicate character. So in this situation, so this substring has duplicate characters, so A and A is repeated. So my function is going to remove all the substrings which has a duplicate character. After removing it, we need to go through the string again and find the length of the longest substring. Okay, so this is of n square time complexity, because to generate all the substring, that's going to be like 2 for loops and it's going to be of n square, and after that it will be of n for removing the duplicate characters and so on. Okay, now let us look at the second approach, which is a sliding window approach. In this approach, I'll be taking 2 pointers, a start and then end. Both will be starting at the 0th index, and I'll start traversing through the string with the help of the end pointer, and I'll traverse through each and every character, and I'll start storing all these characters in a set. Okay, so this is how it goes. So initially I will take a set, and that's going to be an empty set, and I'll traverse through the string using the end pointer. I'll check if this character at this end pointer is it present in the set or not. If it is not present, then I will add it. So as set is empty, we will add A to the set and we'll increment the pointer here. Okay, now check if B is present in the set or not. As it is not present, add B to it. Same thing as check if C is present or not. C is not present, so we'll add it C to the set. Now when you come to A, okay, now end pointer is here. Now check if A is present in the set or not. As A is present, we'll stop our end pointer here and we will remove the character which is present at the start pointer from the set. So the character which is present at the start pointer is A. Now remove A from the set, okay, and we increment the start pointer. Now the start pointer moves to here. Now again check the character in the next iteration. We will check the character at the end position, is it still present in the set or not. Okay, now the character at end pointer is A. As check if A is present in the set or not. As A is removed, now we are good. Now we will add A to the set again and we'll increment our end pointer. Now check if B is present in the set. So as B is present in the set, what we do is we remove the character at the start pointer and increment the start pointer here. Now in the next iteration, check again if B is present or not. So as B is removed in the earlier iteration, we add B to it again to the set and we move end pointer to C here. Okay, now check if C is present in the set or not. As C is present in the set, what we do is we remove the character at the start pointer, which is C, and increment the start pointer. And In the next iteration, again check if C is present in the set or not. As C is not present in the set, we will add C to it, and we'll increment end pointer here. It will be at B. Now check if B is present in the set or not. As B is already present, what we do is remove the character at the start index, which is A. Now A gets removed and start pointer will be incremented to here. In the next iteration, again check if B is present in the set or not. As B is still present in the set, what we do is we repeat the same process for the start pointer. Remove the character at the start pointer, which is B, and we'll increment our start pointer here. And again you check if B is present in the set. As it is not present in the set, we add it. Like that, we make use of two pointers, start and end pointer, and try to find the longest substring without repeating characters. And in order to find the longest substring, what we do is we will just do a simple computation. Like when your end pointer is at here and your start pointer is at here, the longest substring, the length of the substring is calculated as end minus, so it's going to be, let's say if you assume it as a target, that's going to be end minus and start pointer plus 1. That's the length of the substring between the start and end pointers. Okay, this is the second approach. And what is the drawback of this approach? So this is a O of n time complexity approach, but if you consider some string like this, let's say, let me take an example of A, B, C, D, E, F, G, G. Now, according to this approach, we add all the, so we'll have a start pointer here, end pointer here, and we add all the characters to the set. So we add A, as A is not present in the set, we add B, C, D, E, F, G, and our end pointer is here. And after adding G, we go back here again and then check if G is present in the set or not. As G is present, what we do is we remove the character at the start pointer. So A removed, and we'll increment start pointer here. And again we check if is G still present in the set or not. It is still present, so we'll have to increment our start pointer again. We repeat the same process till our start pointer reaches to this position. So if you observe this, we're actually traversing through the string again 2 times, right? This is the worst time complexity in this. How can we improve this approach? So if we can find the index of a duplicate character in O of 1 time complexity, this will be an efficient approach. Okay, that is what we will be using in the third approach. Okay, now let us look at the third approach, making use of a map. We will use the same approach as a sliding window, and we'll have a start pointer here and end pointer here. And here, instead of using a set, we will be using a map. Okay, so map is going to hold the character and their respective indices. So we will be traversing with the use of an end pointer, and initial or map is going to be empty, and we will check if this character is present in the map or not. As it is not present, we will insert the character and then that index, which is 0, and we'll increment our end pointer here and check if B is present in the map or not. As it is not present, we'll add that one to the map and with that index, and then increment end pointer here. C gets added to the map with that index. Okay, now and you move end pointer to here, check if A is present in the map or not. As A is already present in the map, what we do is in the earlier approach, as if the character is already present in the set here, we were moving the start pointers one after other. If you look at this, we were moving start pointer one after other, and then we checked if that character is still present in the set or not. But in this case, as we are maintaining the indexes of every character, so what we can do is we can directly move our start position to that respective index. So in this situation, we move our start pointer to the index which is present in the map plus 1, okay, which is like the character, the index of this character, the duplicate character is 0. Okay, our start pointer, anyways, it is already present in the same index. So what we do is we increment 1 to it. So we are moving our start pointer to this. This is a O of 1 operation. Now, and after doing that, we will update our start pointer, because the latest a character which is present is at this index, which is 3. Okay, so we update our index of the start pointer. Now a index is updated in the map to 3, and we will increment our end pointer here. Now check if b is present in the set or not. Yes, b is present. At that point of time, what we do is we take the index of b and we move our endpoint, our start pointer +1 to it. Okay, so the index of b is 1, as start is already present there. We add 1 to it, so we move start point to this and then repeat the same process. Now end pointer is at here. Sorry, before that we will update the location of this end pointer, which is 4. Now see, check if c is present in the map. Yes, it is present. And what is the index? It is 2. Okay, so which means that c character is present at the second index, another duplicate character. Okay, now what we do is we take that, we move our start pointer to this +1, which is third index. Okay, so start pointer will be moved to this one, and we increment the latest c pointer, which is at 5. Okay, and we move our end pointer here. Now check, is b present in the map or not? As b is present in the map. Now where is this p present? So this p present is present at 4. Okay, now b is, as b is present at the 4th location, we will increment our start pointer to 4 + 1, which is here. Start pointer directly goes here. Okay, so this is how we can make use of map and then move our start pointer in O of 1 time complexity. Okay, so if we look at this example, so with this approach, what we do is we create map and then we store all the indices like A0, B1, C2, D3, E4, F5, G6, and now when you encounter a duplicate character at this position, which is G, now check what is the index of G, which is 6, and we move our start pointer to 6 + 1, which is, so start directly, earlier start was here and the start gets directly moved to here. Okay, so we are eliminating the entire process here, making use of this index. Okay, this is what we will be implementing in the code. Now let's see how we can code the third approach here. Okay, first of all, null checks. If s is equal to null or s dot length is equal to 0, then we just return 0, and we'll have 2 pointers, start 0 and also starting from 0, and we'll have the target, which is 0. That's what we want to return at the end. What is the length of longest substring? And we'll take a map of character and their indices, the index where that character is present, new hash map, and it'll traverse using the end pointer where s dot length, we traverse till the length of the string. Let's copy the character at the end index. So just to keep it simple, so I'm just saving that character into new variable as dot char at of end, and now we'll check if this character is present in the map or not. If map dot contains key of this character, if it is present, then what we need to do is we need to get the index and move our start pointer plus pointer to that, basically +1 to it, right? Otherwise what we do is we'll just add that index, so and then that character, so we'll put that character and that respective index, which is end pointer. Okay, and we'll come back to this one in a few minutes. After adding all these things, what we do is we need to calculate the target. Okay, so the target is going to be math.maximum of the current target with end minus start plus 1. As we are in while loop, we'll just increment our end pointer plus plus, and at the end we'll just return the target. And here, if you encounter a character, duplicate character, let's take this as a string abcabcbb, and so you'll start pointer here is going to be here, end pointer is going to be here. You'll keep adding all the characters, and when you encounter a duplicate character, now you want to move start pointer one position after the duplicate character position. Okay, so your map is going to be formed like this: A0, B1, C2, and when you encounter B, you want to move your start pointer to this position. Okay, which is nothing but one character plus the index of this duplicate character. Okay, so that's going to be start is going to be map.get of the character, map.get of B is gonna return the index which is at 1, and we add 1 to it. Okay, and after doing that, we increment the index of this B. Okay, so that's going to be map.put of ch. Okay, ch is nothing but this with the current index, so that gets updated to the index of this. So A, B, 0, 1, 2, 3. So B gets updated to this. Okay, so this is how we can write. And another thing we need to do is here, if you look at this, when you are at B, your start pointer is moved to this position. Okay, and your end pointer will be moved to this position. Now when you're checking if A is present in the map or not, A is still present and the index is 0. Now you cannot move the start pointer back to 0 again, because if you move that, there is a possibility that you will encounter another substring inside in between start and end pointers, which is having duplicate characters. Okay, so if your end pointer is here and your new index, whatever you are getting here, if it is less than the start index, then you don't want to update your start pointer. Okay, so that's for that reason what you do is the start pointer, you will need to do math.maximum of the current start pointer with this one. Okay, in this situation what happens is, so math.maximum of start is going to be, so this is how it happens. So when you are at A here, so that's going to be math.maximum of the current start pointer, which is 2. It will keep it here, and math.get of ch, which is map.get of A, which is gonna return 0 plus 1, which is 1, so which is maximum 2. Okay, so we'll keep our start pointer at the second position. We will not move our start pointer to this position. Okay, that's the reason we have this math.maximum check. I hope that makes sense. Now let's run the code. Okay, let's submit the code. So this is how we can solve the problem, and subscribe to the channel to see more videos. Thank you.